Hey there guys, got a video here for you today on the BSA R12, and in this one we're going to be making a reg tester for the rifle. Now unfortunately you will have to bear with me a little bit. I have unfortunately recently hurt my back and it's making everything about 100 times harder than it needs to be. So I did miss out on some shots, particularly on the mill, but I did manage to capture most of the things I wanted to. And we did get some footage of the laser engraver doing its thing on the finished part, so you'll see that at the end of the video. For now though, the first thing to do was to chuck up some stock in the lathe, then turn the OD down to 38mm. This stock was very close to 38mm already, so we only had to take a very light pass over the face. With that done, we can concentrate on the very end of the piece, and this end will house the male M25 by 1.5 thread on the end. The part we're making first is the end cap, and this will be the smaller of the two components with the male thread and the attachment for the regulator gauge. In other words, this will be the low pressure side of the regulator. As this is a metric M25 thread, we simply need to turn the OD down to just under 25mm. And we're just taking that nice and slowly with 2mm passes, just using a tiny bit of WD-40 just to keep everything lubricated. I don't like using tons of lubricant when the camera's out, as it does tend to just splatter all over the lens. With the OD down to 25mm, we can start work on the thread features, and that includes facing the shoulder and then cutting the thread gutter or the undercut behind the threads. Now this will be a dual purpose undercut. We will be putting an O-ring round this thread here, so we're just cutting the undercut down to our required dimension, and when it all goes together we will have an O-ring placed around this groove here, and that will seal on the female thread that you'll see us make very shortly. We can then put a nice large chamfer on the end and then start threading. As always, we are using a metric full form cutting insert, and this insert cuts both the root and the crest of the threads, so the top and the bottom side of the threads. These thread inserts are a lot nicer than the standard thread inserts, as they leave a wonderful finish on both sides of the thread, and you don't get any jaggedy edges when you take your finish passes. The real downside to them though is that they are pitch specific, so you have to buy a different insert for each pitch of threads that you're cutting. They can get fairly expensive, but if you're nice and careful with them, they do last a long time. The actual holder that I'm using is a Simtech TE3, and the actual model is a Simturn E3. With that holder I can cut threads, I can make grooves, and I can do a lot of external profiling. It is a really handy tool, although it is fairly expensive to get set up, but I do quite like using it. With the external threads cut, we can move on to the internal features, and on this side we're just drilling out the centre and then tapping it 8th BSP. Our gauge has an 8th BSP thread, and that's fairly common in the airgun world, so we're just whacking one of those in there. The thread will be sealed by a doughty washer, so we're just tapping all the way through. With that done, to finish off the part, we can knurl the external diameter so that it's nice and grippy, as we will need to screw this on and off as we install our regulator. And then once it's knurled, we can 45 the ends just to take off any sharp edges. With that done, we can part the piece off just using a standard part off tool. And whilst that's cutting, I am just putting a fair amount of WD-40 around the tool just to keep everything nice and lubricated. Generally speaking, if you keep everything lubricated and keep everything moving, the parting off procedure does go fairly smoothly. But once we're all the way through the piece, we can flip it round and just quickly finish off the other side. All we need to do on this side really is simply face it, put a chamfer in for the 8th BSP threads, and then just clean up the chamfer on the external diameter. With the end cap made, we can now move on to the body of the reg tester. This will be the piece that the regulator actually pushes into, and to begin with we're just facing the end of a piece of material and then turning the OD down to 38mm. With that done, we can start work on the internal features, and to begin with we're drilling straight through the piece with a 7.5mm drill bit. The piece will be about 80mm long, so we are taking it nice and careful, retracting the drill every now and again to clear the chips, and using a nice amount of WD-40. Once we're all the way through, we can swap out to a 14mm drill bit and drill down to about 55mm deep. Once we've drilled the centre out with our 14mm drill, we can swap over to a nice sturdy boring bar and bore the end out to 22.5mm. Again, we're only going about 55mm deep, and it's critical at this stage to get a nice surface finish on the internal walls. So we're just taking the internal diameter out nice and slowly, and then once we're near, we can measure it and take a nice finish pass. With that done, we can chamfer the end of the work and then use the regulator to test the fit. The regulator body is around 22mm and the O-ring OD is around 23. So we went with 22.5 to give a little bit of clearance between the body and the regulator tester, and then that's roughly a 0.5 squeeze on the O-ring, which should be plenty for this application. With that done, we can start work on the female threads, and as we're using a standard metric form, to work out the internal diameter, it's very simple. We simply take the nominal size of the threads, in our case 25mm, and then take away the pitch of the threads, so 1.5. That leaves us with 23.5, so we simply need to remove about 1mm of material out from the very end of the work. With that done, we can turn out a little more of the end for an O-ring groove. This will be the surface that the O-ring groove that we cut in the end cap will seal into. So we're just cutting that out so that we've got a good amount of squeeze on both the external diameter and the width of the O-ring. So it'll be squashed both back and front and top and bottom. With that done, we can put some nice chamfers on everything, and then using an internal grooving tool, we can cut out the thread gutter in the back there. With that done, we can swap out to a threading boring bar and put our M25 by 1.5 thread in. This boring bar isn't a full form cutter, so it doesn't cut both the root and the crest, it simply cuts the root of the thread. However, it is still fairly sharp and it does produce a nice finish on the threads. As we already have a set of male threads, we are just cutting until we get a good finish and a good fit between the male threads that we cut earlier. And then once we get close to our calculated thread depth, we can test fit the end cap and just keep going until we get the fit we desire. The last thing we'll do is just put a nice chamfer on the internal bore, and that'll just help us install the reg and make sure that we don't cut the O-rings as we push the regulator into the body. Final thing to do on the outside is simply knurl it and then use our 45-degree chamfer tool to just put some nice decorative chamfers on it. Then we can part it off and get the component finished. The only things I didn't show on camera was parting the piece off. We did then have to flip it round and finish the other side, although that was nice and simple, as we just drilled it out, tapped it 8th BSP, and then put a nice 45-degree chamfer on the very end. The only other thing we had to do for the regulator body was drill a small 1mm hole in the side of the body, which related to the breathe hole in the side of the regulator. But again, I didn't want to work around the camera on the mill, so I left that out of this video. The final thing I wanted to show you though is just some laser engraving on the outside of the reg body. It's actually quite hard to video. What I had to do was put the laser safety goggles over the camera so it does look a little green, and as this is aluminium, I did have to use a media painted over the aluminium to get the laser to mark it. The laser won't mark aluminium just as it is. This is a blue laser. I think the fibre lasers will mark aluminium, but the blue laser won't. It does work perfectly fine on steels and stainless steel and also anodized aluminium, but for raw aluminium the blue laser won't touch it. What you have to do is paint this paste over it, and the paste has a pigment in it which, as the laser touches it, it burns it onto the surface of the aluminium. It doesn't scratch off with your fingernail, but if you get on there with a Scotch-Brite you can get it off with a bit of elbow grease. The laser is set up using our rotary tool, and I'll show you the final design at the end of the video. However, it engraves it around the outside of the piece. If I'm honest, it does do a really nice job. I haven't used the laser to its fullest potential yet, but when I get a minute I will have a little play around with it. Right then, that's about going to do it. So I'll let the laser footage play out, then I'll bring you back over to the bench. Right then, so that's how we made the reg tester itself. What I'll do is just get you a good look at it here. so that you can see all the pieces. On this part here, this is the piece that we laser engraved, obviously. Has our BSA logo, as well as our Sub 12 Airgunners logo, as well as the model that this reg tester fits, so the R12. On this piece here, we have an O-ring around these threads here to seal off the base of the unit from leaking to atmosphere, obviously. We have our gauge installed, as well as a bleed screw set up so that we can simulate taking a shot. In this piece here, there is a 1mm hole drilled straight through into the threads. I'm not sure if the camera will pick it up, but there is a 1mm hole drilled straight through. That's capped off with a 4mm ball bearing, as well as an M5 grub screw, which you can see at the top here. What this little arrangement allows us to do is to use a 2.5mm Allen key to loosen the grub screw. What that'll do is allow the unit to leak, allowing us to simulate taking a shot. What that'll do is just cycle the regulator, and we can observe what happens on the gauge. I did also make a new component for the regulator, so if we take a look at the end caps here, you can see the difference between the two. This one here is the original, and our new one is installed. It houses a 5 or M5 tapped hole in the centre there, as well as 2 holes, one on either side. They allow us to install a pair of snap ring pliers to unscrew the end cap. On the original piece, we had to bang an Allen key in the end there to remove it. Doing that obviously wasn't ideal, so we've just gone ahead and remade the piece as it should have come out the factory. The tapped M5 hole also allows us to screw an M5 bolt in there to install it and remove it from the reg tester nice and easily. It's also a lot easier to remove the regulator from the housing inside the rifle with the M5 hole in the back. With that all said and done, what I'll do now is install the reg and show you how it works. To begin with, we'll just install the regulator into the housing, nice and simply like so, being careful of the O-rings as that gets pushed in. Then we can take the end cap and just screw that on. With that done, we'll make sure that the bleed screw's done up nice and tight, which this one is, and now we can attach our whip. As we pressurise the unit up, you can see what happens to the gauge. We're at about 100 bar, so the reg is set around the 100 bar mark. As we take a shot, we can see how it settles. And if I'm honest, this is why I wanted to make a reg tester for the rifle. The regulator is a little sluggish, so if we simulate taking a shot here, you can see we're on about 100. It's not really settling at a defined pressure, but about 100 we take a shot. It drops down to 95. Hopefully you can see that there. I am limited by the whip, unfortunately. But as you can see there, it just keeps rising until it gets up to about 100, then it stops. I haven't actually done anything to the regulator yet, so I haven't cleaned anything up or anything like that. We did take it apart, but I did try and set it to roughly the same reg pressure. We've certainly not damaged anything inside. But as you can see there, it does take a fair amount of time to settle back to 100 bar. So there we have it. What I'm going to do now is leave the unit pressurised for about 10-15 minutes and see what it settles out to. And after about 7 or 8 minutes, you can see that the reg pressure has risen to about 101.7. So not fantastic, but not terrible either. I am probably going to take the regulator apart, give the working surfaces a little polish up, see if we can improve the creep slightly. To be honest with you, this is the worst case scenario for a regulator. We have an extremely tiny plenum, we're hyperanalyzing it with a digital gauge, so it's the worst possible scenario for the regulator. But I would like to see if we can get the settle time to be a little more reasonable. The regulator is also set a little higher than I thought it was. I had guessed when we first got the rifle that the regulator was set around the 80 bar mark, as at 80 bar the feet per second just seems to fall off the face of a cliff. But I am probably going to be changing the reg pressure anyway, so the current reg set pressure doesn't really matter too much. With that all said, I'm pretty much done with the tester now, so we'll dump the air out, then we'll take a look at the rifle itself. Right then, the final thing I wanted to show you is just the 300cc bottle on the front of the rifle. So we'll take a quick look at it there, and before you ask, there is a gap between the cylinder or the bottle and the shroud. It's just a very tight fit, but I wanted to ask you guys' opinion. So what we've got here is the 300cc bottle compared with the 480. We're going to be making a new shroud for the rifle anyway, so I wanted to hear what you guys thought we should do. Should we go short shroud, short bottle, or long shroud, long bottle, or a combination of the two? So if you've got an idea of what you would like to see, you can leave it in the comments below and I'll read there. I will say for reference, the barrel finishes just about here, so we've got about 2 inches in front of the barrel. So what we could do is make a nice short shroud with a 1/2 inch UNF on the end to accept an additional moderator, or we could do something like the original one and have a reach back mod, which pretty much is reflexed over the shroud, but it'd be nice to hear you guys' opinion. With that said though, that's pretty much going to do it for this video, so thanks for watching and we'll see you in the next one.